we're breaking chapter 4 into 2 chapters. So there's going to be a 4a and a 4b, both of which will have a test at the end of them. So you don't have to master an entire chapter all at one time. You get to break it up. 4a, 4b, okay? Okay, so 4.1a, I'm going to give you a little introduction into parabolas. What's a parabola? It's the U-shaped graph, right? The U-shaped curve. It is. What is that?
I don't know.
Okay. It is the graph. A parabola is a graph of a quadratic function. Do you know what a quadratic function looks like? You're in the right track. The quadratic function is this one. It's y equals ax squared plus bx plus c, right? Remember the quadratic function or quadratic formula? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember that? You don't need to know it. I'm just saying quadratics.
I could not understand what you were saying.
Okay, it's okay. We're not doing the quadratic formula right now. Anyway, yeah, you need to chill. Come back to me. We will be doing the quadratic formula later in this chapter. We are not doing it today, so don't worry about that. We'll get there. So, like I said, quadratic function, you get a U-shaped curve, you get a parabola when you graph that equation. Okay? We're going to start with the parent function. Do you remember the parent function for this? It was y equals x squared. Okay? Do you remember what y equals x squared looked like?
The thing above it.
The vertex is at 0, 0. And then you're going up 1 over 1, up 1 over 1. But instead of the v, right, this is not a v. This is a U-shaped curve. So you're doing a parabola, right? That would be your parent function. I didn't do a very good job of spacing that appropriately. But that's your parent function, okay? In the parent function, the vertex is 0, 0. And then there's this AOS. Do you remember what AOS was? Axis of symmetry. So parabolas are always symmetrical. Jared, are you with me right now? Or are you working on something else? You're with me? Okay. So your axis of symmetry is the place where you could fold that parabola and it will match up perfectly on the other side. Okay, so my axis of symmetry would be that green line. Your axis of symmetry in this problem is x equals 0, right? Axis of symmetry is always x equals something, okay? You have to make it an equation because it's a vertical line. The equation of a vertical line is always x equals some number, okay? Okay, with that parent function, do you know what the domain would be? Do you remember what domain is?
0, 1, 2, 1, 2, 3.
Would it be x equals x squared?
No. Domain means what are the possibilities for your x values, right? So here's the thing. The arrows on the end, that means they keep going, right? And if you were to let that keep going forever and ever and ever, it won't ever stop. So eventually it's just going to keep moving wider and wider and wider. So your domain for every single quadratic is all real numbers. Please don't ever get that wrong on a test. It is always all real numbers. It will never be anything else for a quadratic. No. All real numbers. So do you know how to do all real numbers? It's just like parallel lines there, and then you turn it into an R. That means all real numbers, okay? The range, however, is not always the same. The range changes. So if you think about this setup, range is your y values. Think about what y values exist on this graph. Is there any y value down here?
No.
No. So the first y value is 0. And then it could be any number above that because those arrows just keep going, right? So my range is going to be that y is greater than or equal to 0. Okay, so you're going to have to do some of that as we go. If this A is greater than 0, it's going to open up. Okay, if your A is less than 0, in other words, if it's negative, that's when it opens down, this A. Okay, so in our parent function right now, what is our A?
0.
It's 1, right? That's why it opens up. Okay? Okay, all that to get us to the form that we're really going to be working with. So this is just the parent function, okay? We are going to work more, I'm going to run out of room here. Yeah, maybe I won't. We'll try not. Actually, no. I'm going to work over here. You're welcome to go underneath. We're going to work in vertex form. Okay, and this one should look really familiar to you because we did this with absolute value. Now we're just doing it with the quadratic. So vertex form looks like this. Y equals a times x minus h squared plus k, as long as a isn't 0. Okay. Recall for me, yes.
Just make sure, the squared does not mean h squared, just x squared.
No, it doesn't mean either of those things. It's saying, I mean, essentially, if you were to work it out, it's x minus h squared is x minus h times x minus h would be x squared minus xh minus xh plus h squared, right? But we don't need to do that in these problems. But if we were to like work out x minus h squared, it would be foiling, right? But you're not actually going to physically square things right now. We're just looking at the format of the equation, what it does for us. Hopefully that will become more clear as you see what we're doing with it. Okay, so in this setup, do you remember what this h was?
Height.
Not height.
How-
How about h and k together? Do you remember what h and k? It was your vertex, right? Okay, so here's the deal. Your vertex in this setup is always going to be hk. Okay, remember h is going left to right, but opposite of what it looks like. If it's minus h, it's actually going to the right. If it's plus h, it's actually going to the left. What is your k doing?
Up and down.
Up and down. So if it's positive, it's going up. If it's negative, it's going down. Okay, so that's your vertex. Your axis of symmetry in the vertex form, your axis of symmetry will always be x equals whatever your x value of your vertex is. So x equals h is always your axis of symmetry. Okay? Always a vertical line. Okay. Then the last thing before we actually start doing some of these, you will see minimums and maximums. Minimum versus maximum. And I just want you to think about how this goes. If I have a graph that looks like this, and I have another graph that looks like this, okay, which one of these has a minimum?
Right, mid, left.
The left side, right? You're looking for what is the minimum, the low point, okay? So my minimum is right here, right? That's a minimum. When it's got the negative and it flips upside down, that then is my maximum. So it's the highest point of my graph is called a maximum. The lowest point is called your minimum. It will be one or the other. You can't have both in a problem, okay? Not in a quadratic anyway. So it's always going to be at your vertex, and we'll know what our point for our vertex is, so you'll know what your minimum and maximum are, and I'll show you that in a more real-world situation shortly. Any questions on that? Okay, maybe just make a note. This is if A is positive. This is if A, I should probably write the word, not the sign. Oops, negative. Okay, so if your A is positive, you have a minimum. If your A is negative, you have a maximum. Are we ready to try a few?
Sure.
Okay, let's do this. All right, so let's look at number 1 here. It says make a table of values and graph the parabola. Now, if you're looking at this setup, the 1/2 is your A. There is no H, there is no K. So what is our H and K? 0, 0, okay? Our vertex is 0, 0. We didn't move left to right. We didn't go up and down, okay? But we're gonna make a table of values just to make sure things are lining up the way we need them to line up. So 0 is always a great place to start, okay? If you plug in a 0, 1/2 times 0 squared, you're gonna get a 0 out of that. So 0, 0 is a point on our graph. Okay, if we plug in 1, 1 squared is 1 times 1/2 is 0.5. So you're gonna go 1.5, okay? If I plug in a -1, what do I get? You get 0.5 again. So that's gonna go right here. Okay, let's do one more number here. If we plug in 2, so 2 squared is 4, cut that in half, you get 2. So the 0.22 is here. Now here's the beauty of parabolas. You don't need to plug it in for both sides because they will always reflect over your axis of symmetry. My axis of symmetry right now is this y-axis. So if I just flip that over my axis of symmetry, I'm gonna end up here, right? I didn't have to plug the numbers in. I just know it's gonna be there. They're always symmetrical, okay? So my graph is going to look something like that. Questions on that? Okay, one place to be careful, notice this. Before we said you can kind of think of that as a slope. It is not a slope here, right? These are not linear. They don't draw a straight line, so you don't have a slope. What you can think of it as is we went up 1/2 and over 1. So you can almost think of this as the top number of your slope. You went up 1/2 and then you went over 1, but you can only do that for 1 point on either side, okay? If I were you, I wouldn't do that. When it's a fraction, it just doesn't work as nice. When it's an integer, you can always do it, but the fractions kind of throw people off. So I would just make a chart, make a table, and do it from there. Okay, next one. What's your vertex on this one? Did we move left to right or up and down? No, we haven't, right? So your vertex is going to be 0, 0 again. If you plug in a 0 here, you get a 0 out. Okay, so we plot 0, 0. What if we plug in a 1? What do you get when you plug in 1? -3, right. So 1 squared times -3 is -3. So 1, 1, 2, 3. Okay, what if I plug in a 2? God bless you. 2 would get you, God bless you. 2 gets you -12, which is way off your graph, right? That's like way down here somewhere. Because you're doing -3 times 2 squared. So 2 squared, remember PEMDAS? Gotta do the exponent first, then you can multiply. Did you multiply first? If you put them into your calculator exactly how you see it, like parentheses and everything, it does. But you have to be very detailed then with how you plug it in. Okay, So here's the thing. Your other one's going to be way down here somewhere. You don't even need to plot that. It's way out of the thing. But your opposite side, your reflection, you do want to plot. That's right here. And then this is a U-shaped curve. So it's going to look something like that. Okay? Why is it upside down?
Because it's a negative trace.
Because there's a -3, right? That flips it over. Okay? One other thing to notice, and then I'll get to your question. When it was 1/2, notice this, it was fatter, right? When it was a -3, it's narrower. So when your absolute value is like, the bigger it is as an integer, the wider it gets, the smaller, like as it goes to fractions, that's when it gets, sorry, I said that backwards. The bigger the integer, the narrower it gets. Is that what I said? That's what I meant to say. But then if it's a fraction, the fractions open it wider. Okay? So you'll kind of see that as we go.
Get those questions on the test where it's like, what will this
Yes,
look
we
like?
will get these on the test.
I mean, you'll have to graph them.
So will it say describe what it looks like? What describe what it
Um,
They give you the same if
I wish they gave
if you're asking what it.
Potentially. You should be able to tell me if it goes wider or narrower or whatever. All you have to do is graph it and you'll know, right? Okay. Now we're going to graph just using shifting. So we're not going to plot our, oh yes, your question. Sorry. What's up?
How come you use different numbers for the first table? Like, does it matter?
Oh, so you don't need to use a -1 on this table because you could just reflect it, but I wanted you to see that it works out, right? So if you do, 0, -1, -2, 1, and 2, those 5 are great numbers to use if your graph hasn't shifted anywhere. If it's shifted, then those aren't great numbers anymore. I'm going to show you how it shifts right now, and you can graph with the shift without doing a table of values. So I'll show you right now. Okay, so graph using shifting. Tell me what this -5 is doing to your graph.
It puts it down 5 dots.
It's taking your parent function, and it's just taking it down 5, right? Okay, so we're going to start at 0, 0, go down 5. 1, 2, 3, 4, 5. That's my vertex, okay? There is no a value there, so your next 2 points can just go up 1 over 1, okay? So I can go up 1 over 1 here, up 1 over 1 here. I like to have one more set of points. So if you do want to do a table of values, what point would be a good number to plug in for x? 2. Let's plug in a 2. So if I do 2 squared minus 5, I get 4 minus 5 is -1. So 2, -1 is here. Do I need to plug in -2? No, just reflect it, right? My axis of symmetry is here. Isn't this stuff fun, guys? I love this stuff. So reflect it over here, and that's your graph. Draw in your U. Make sure you're not trying to draw straight lines. They're not straight. They're curved. It's a U shape. Okay?
Doesn't it get to a point that
What's the domain of this?
all real numbers?
All real numbers. Please don't get that wrong. I'll cry. What's the range? What are your Y value options?
Y is greater than -5.
Or equal to,
Or equal.
right? Y is greater than or equal to -5. Here we are at -5. Every Y value is above that, right? So it can't be less than -5. It's anything greater than or equal to -5. Are you with me right now?
No.
Put that away and do this. Okay, let's do the next one.
Oh, I already messed up.
Where is this graph going? So notice it's inside. So left or right or up and down?
It's going to
It's going left or right. It's +1. This is opposite.
So it's going to the left.
It's going to the left one. So you're taking your parent function and you're going left one. Okay? Guys, this is going to be awful if you don't pay attention right now. Pay attention. Left one. Okay? So you're here. That means that's my vertex, which means my axis of symmetry is at -1. So when you reflect, don't reflect over the y-axis. It won't work. Reflect over the axis of symmetry. So if I go left 1, then you can go up 1 over 1 for your next 2 points, because there's no a term out in front of there. If you want one more point, which I highly recommend, what's a good number to plug in for your x right now?
8, 1.
Plug in 1, right? That would be the next point over. So if you plug in 1, this is 1 plus 1 squared. So 2 squared is 4. So plot the point 1, 4. Okay, now we're going to reflect it. Be careful when you reflect. We went 2 to the right, so you need to go 2 to the left. That means my graph looks like this. Okay, it's my parent function, just shifted 1 to the left. Do you see it? Okay. This one. Okay, now we're getting a little fancier. What's your vertex?
2, 1.
2, 1. It's the opposite of this one, the same as that one. So your vertex is 2, 1. So you're going to go 2 to the right, 1 up. Okay, that's my vertex. That means my axis of symmetry is right here. Okay, what's a good number to, well, so you can do your next 2 points, right? Up 1 over 1. What's a good point to plug in then? Plug in 0. 0 is an easy number to plug in because it gets rid of a lot of things, right? So if I do 0 minus 2 squared plus 1, -2 squared, what's -2 squared?
4.
Positive 4. So this is 4 plus 1. So if I plug in 0, I get out a 5. So 0, 5, 1, 2, 3, 4, 5 puts me here. Reflect it. So now we got to go to the right of our axis of symmetry, and that would be my graph. Okay, and here's the thing, guys. If you don't remember the little details of it, plug in points. All you got to do is plug in 0, 1, 2, plug in those points, see what you get. Okay? You don't even need to necessarily remember like the rules of it. Okay, last one of these, and then we are moving on to the next thing. First of all, when you look at this -x squared plus 1.5, is there anything you can tell me about the graph before we do a thing? Which means what? Upside down, right? Okay, so where is it shifting?
Up 1.5.
Up 1.5. So there is no left and right, so up 1.5 is going to put our vertex here. But like we said, it's negative. It's going down. So don't go up 1 over 1 right now. Go down 1 over 1. And be careful what down 1 looks like. You're halfway, right? So it's got to stay halfway if you move a solid 1. So down 1 over 1 would be there. What's a good number to plug in right now? We already have 0. Plug in 2 for your x. Here's where you have to be careful. This is saying the opposite of 2 squared plus 1.5. What is the opposite of 2 squared? -4. That negative doesn't go away. It's not in parentheses, right? So this is -4 plus 1.5. So if you plug in a 2, you get a -2.5. So 2, -2.5, and then reflect it. Here's our axis of symmetry. So reflect it over that line. You get this graph. Oh, I totally missed it. Pretend I didn't. Okay. What's your domain on this one? All real numbers. Don't get that wrong. What's your range?
Y is less than or equal to 1.5.
Y is less than or equal to 1.5. Okay? Okay, now we're going to lump all kinds of things together.
So
Here we go. Number 3 here. What is your vertex?
4, -2.
You do the opposite of this one, the same as this one. So your vertex is 4, -2. Okay, so go 4, negative 2, 1, 2, 3, 4, 1, 2. That's my vertex. Okay. What is your axis of symmetry? You can't just say 4. X equals 4, right? It's a line. So your axis of symmetry is this line at x equals 4, right? Whatever your x value of your vertex is, x equals that is your axis of symmetry. Okay? Okay. Then it says graph some extra points. What are some good numbers to plug in?
0, 3.
0 is a little far away from what we're doing. 3 would be a good one. Now here's the thing. Notice up here, you have 3 out in front. That's your a value. Remember I said on your first one, you can move that as your like slope. It's not a slope, but you can move it as long as that's not a fraction. You can do that move. So you can go up 3 over 1 and reflect it. Okay, if I want one more point, then what would be a good number to plug in? I would plug in 2, right? If you plug in 2, you'd get 3 times 2 minus 4 squared minus 2. 2 minus 4. Oh, here's the thing. Here's where your calculator is so nice. Your calculator has parentheses. If you plug it in exactly like that, your calculator will do the work for you, but you need to put the parentheses in. So 3 parentheses 2 minus 4 parentheses squared minus 2. You get, oh, I didn't plot them on here. You get 10 for that, which is gonna fall off our graph. So I'm not even gonna plot that one, but you can graph this one, okay? But don't hesitate to just plug it in, but just be careful that you're plugging it in with parentheses, okay? Okay, so this one's a minimum. What is your minimum?
4,
Negative 2. It's whatever your y value of your vertex is your maximum or your minimum. So your minimum is negative 2. Okay. What's your domain?
All real numbers.
All real numbers all day long. What's your range?
Y is greater than or less than negative. Greater than or equal to negative 10.
Right, your range is whatever your y values are. Your lowest y value is here. Everything else, all your other y values are above that. So you have to say y is greater than or equal to negative 2, because it can be any y value greater than that. Okay? Okay, Y-intercept. We haven't talked about this one. How do you find a Y-intercept?
You put math.
You put math, sure.
You have to find Y.
We want the Y-intercept. Where is it going to hit the Y-axis? What's your X value on your Y-axis?
0.
0. So when you're trying to find a Y-intercept, just plug in X equals 0. Okay? So if we take this, 3 times 0 minus 4 squared minus 2. That's going to be your Y-intercept. Again, plug it into your calculator. It's much simpler. You're welcome to do PEMDAS one piece at a time. That's totally fine, but your calculator will do this for you. Let your calculator do it if you'd like. So your Y-intercept is the point 0, and that comes out to 40, not 42 actually, 46. Okay, so your Y-intercept is 0, 46. Questions on that? Okay. Yes.
I'm gonna hit the restroom. I might come back with a football jersey. I might not. I gotta get the bus, so I might not have time to get it. So if I might need to go run around real quick.
The bus has not left yet? What are you talking about?
For tomorrow. Don't worry, I will take.
Oh, no, don't, no. You're not gonna go get a football jersey right now. No. Why can you not do it after I'm done teaching the lesson? You can.
How long is this?
You can. What does it matter? Well, sit down and do the math. I like how you think you're just gonna tell me, like, here's my plan. This is what I'm gonna do. No. All right, this one. Here's your equation. What is your vertex?
-3,
negative 3, right? Opposite of this one. Same as this one. Negative 3, 4 is your vertex. Okay, your axis of symmetry is x equals negative 3. It's always whatever your x value is. So if you plot negative 3, 4, 1, 2, 3, 1, 2, 3, 4. Okay, negative 3, 4. Axis of symmetry is x equals negative 3. Technically, you don't have to draw that line in. I just think it's helpful for reflecting. I would draw it in if I were you. Okay, so if we're going to graph some extra points, first of all, you have a negative 2 there. So you may do one move of negative 2, right? You're going to go down 2 over 1, down 2 over 1 on both sides. Let's plug one more point in just to see where it ends up. What point's a good one to plug in? If we go right next to it, it would be negative 1, right? So you're going to go negative 2 times negative 1 plus 3 squared plus 4. And again, let your calculator do your work. Negative 2 parentheses negative 1 plus 3 squared plus 4. You get negative 4. So if we plug in a negative 1, we get for y a negative 4. So negative 1, 1, 2, 3, 4 puts me here. So reflect that. I get that point there. Draw that line in. Remember, this is a curve. We want to be curved. What is your maximum? It's always the y value of your vertex. So your maximum, the highest point on your graph is your y value of 4. Okay? What's your domain?
I thought the minimum was
All real numbers.
the y value.
It'll either be a minimum or a maximum, right? We don't have a minimum when it's upside down. So then you want your maximum. Domain is all real numbers every single time. What's your range? Where can your y values fall?
Less than or equal to 4.
Less than or equal to this right here, right? Y is less than or equal to 4. And how do you find a y-intercept?
0.
You plug in 0.
Ms. Rubin,
Yes.
on the homework you're asking for the maximum and the minimum.
Not on the same problem. And?
I think they're asking.
Or. Yep. You should probably just pay attention to the lesson so that
I am.
you're not. You're doing the homework.
I'm multitasking.
Multitasking is a fallacy. Yep, it's true.
Okay, but I can't.
That is false.
All right, so if we plug in 0 for x, it's going to look like that, right? Negative 2 times 0 plus 3 squared plus 4. Your y-intercept then, and here's the thing, y-intercept is a point, right? It is 0, and you get a negative 14. So 0, negative 14 would be your y-intercept. Okay? Questions, comments, concerns? Yep, we're going to take a break right now. So we're going to skip those 2. We'll come back to them. But we're going to pick up right here because this is new. Those 2 are review. Normally these would be on separate days. Okay, here's the scoop. Stick with me on this because if you don't get this, you're going to be real confused trying to solve these problems. This says, write the equation of each parabola in vertex form. Okay? Vertex form is this one. Y equals a, excuse me. Right? So we need to get this into that form. Okay? You should be able to set it up for me with H and K right now, right? Vertex form, your 3 is your H, your 2 is your K. So let's just set it up with H and K plugged in. What would that look like?
Y equals parentheses x minus 3 parentheses squared plus 2.
Right, don't forget your A out in front. Okay? This is vertex form. If you can do that for me on the test, I will give you a point. Even if you don't get any further than that. If you can set it up with the vertex in, I will give you a point, okay? What we're gonna do is try to fill in the rest of the unknowns. So we need an A, because that's our other unknown in vertex form. Okay, your x and y, when you're all said and done, x and y will still be x and y, but to find A, we're gonna replace x and y, okay? So you kind of put something in and then you take it back out at the end, okay? Here's what we're gonna do. You were given a vertex, which we plugged in, and a point, which we haven't done anything with. That point is going to be your x and y in that equation, okay? So we're gonna do, what's y? 5 equals a times x is 1 minus 3 squared plus 2. All you have to figure out here is an a. So now we just simplify. So 1 minus 3 is negative 2. What's negative 2 squared?
4.
4. So we have 4 times a
What's the A stand for?
plus 2. It's just, it's a placeholder for if we're going to be wide or narrow or upside down or right side up. What? It's not your slope, but it's like your slope. What?
Never mind. I think I just mixed two things except together.
Oh,
It's okay.
okay. So right now it looks like this. What do I do to solve for a?
Yes, subtract 2.
Take away 2, take away 2. Okay, so 4a equals 3. Then what? Divide by 4, right? If we're trying to isolate a. Okay, so here's the deal. A is 3/4. That's great. That's not our answer. Our answer is vertex form. So you're going to take this and plug it in here with your original setup, and you're done. Okay? It's going to look like this. Y equals 3/4 times x minus 3 squared plus 2. That is vertex form of that equation. Or of those 2 points, sorry. Okay? Let's do it again. Yes. Okay, so you have a vertex and you have a point. Your vertex is h and k. Your point is x and y. So we're going to plug it in without the x and y first. Okay, step 1.
It's similar.
It's similar, yeah. You haven't done this exact thing. Okay, so y equals a times x what? What comes next? No. X minus h. So x minus 2 squared. Then what? Minus 3. It's a negative 3, so minus 3. Okay? Remember the formula, the initial formula? Looks like this. This one is subtraction. This one is addition. So subtraction, if we're adding a negative, then you just call it minus 3. We'll talk about it later. Okay, so that's your first step. What's your second step?
You gotta
Plug in the x and the y. Okay, so we're going to plug this in. The x is going to go here, the y here. So negative 8 equals a times 4 minus 2 squared minus 3. Now simplify. PEMDAS, people, right? Follow PEMDAS. So in the parentheses first, 4 minus 2 is 2. Then your exponent, 2 squared is 4. Oh, look, we got a 4 again. 4a minus 3 equals negative 8. Add the 3. So negative 5 equals 4a. Divide by 4. So a is negative 5 over 4. Okay, so you have your a. Step 3 is to plug it in to your original step 1, right? This is just going to go there. So it's going to be y equals negative 5/4 times x minus 2 squared minus 3. Problem solved. Okay? I won't make you do this one right now, but I want you to think through how you would do this one right now. So if this was the same problem, you need a vertex and you need a point. Can you find a vertex for me?
Vertex is
3, 1. Okay, so you would use a vertex of 3, 1. And what would your point be?
0, 7.
I would pick 0, 7. Right? Here's a point that falls perfectly on the graph, 0, 7. So I would do those and then do what we just did on those last two problems. If you want to try that, I'm happy to give you the right answer and let you try it. I'm going to do that. I'm going to write the right answer right here. If you are not feeling confident in this yet, try this one a little bit later, but write this down because this is the right answer.
Can you go back to what you just read?
Yep. So this is what the answer should be when you're all done and through on that problem, if you want to try it on your own. You'll do them in the homework too, so. Is that enough for that one? Oh, oops. Any questions on that? Okay, let's just do one more of those top ones. I don't care which one. Do you have a preference? Pick one of these. Number 2? Okay, we're going to do number 2, and then we're done. You guys have been troopers. Keep up the good work. What is our vertex here? -2, opposite here, same here. So vertex is -2, -1. What's your axis of symmetry? Hey, you're not talking right now. You're doing this with me right now. X equals -2. Whatever your x value is, that's your axis of symmetry. So plot -2, -1. Does this open up or down? It opens up because it's a positive A. Okay. How do you find a y-intercept? Plug in 0, right? 2 times 0 plus 2 squared minus 1. So your y-intercept is 0 something. So 2 squared is 4 times 2 is 8 minus 1 is 7. Okay? So your y-intercept is 0, 7. So you can plot that 1, 2, 3, 4, 5, 6, 7. What's a good number to plug in or a good point to find right now? If you plug in a -1, that would be good. Because you have 2, you can actually go up to over 1. Up to over 1. It should be -1, -1. And then reflect it. Okay, then if you want to reflect it over here, it would be right there. So your graph would look like this. Yeah, Jared.
I thought you said the 2 wasn't a slope.
It isn't a slope, but if it's an integer, if it's 2, 6, -3, -1, you can do it on the first point. If it's like a 1/2, you can't. It's not up 1 over 2 if it's 1/2. It's up a half over 1 if it's a half. Okay? But you're always welcome to just plug numbers in too. You don't have to do that little trick. If you want to just say, nope, I'm going to plug in a -1, then -1 plus 2 is 1 squared, which is 1, times 2, which is 2, minus 1, which is 1. So you get -1, 1. Okay? What's your minimum?
-2.
No. Minimum is -1. What's your domain? Free point. And what's your range?
Y is greater than or equal to -1.
Greater than or equal to, because y is going up. Y is greater than or equal to -1. Any questions?
Or are we done?
2 lessons in 45 minutes.